Hi, welcome. The idea of this video is to show you how to use our application in MATLAB to classify PCG signals in either normal or abnormal. This within a clinical context or for research purposes. Now, this is the application that we have developed in the software MATLAB. The first step into using it is to load a signal, an audio signal. It should be in .wav format. Now, we have two signals here as an example. Let's try the first one. Now here, what we see is the signal being plotted. We can play with this display, we can change the scale of time to process it, to verify things visually, manually within the signal. We can also move it within the graph itself. In here we have the sampling rate of the signal being loaded. And now to the classifier itself. Our classifier, what it does is that it deconstructs the signal into its different intrinsic mode functions. Then it reconstructs the signal with a few of those intrinsic mode functions, or IMFs, and then tries to use our classifier, which is a deep learning network. So here we have the values that are going to be used for the reconstruction of the signal. It will start with the first mode, with the first IMF, and this will be the last value it will use to reconstruct. If you go up to the final value, that in this case is 10, then it will just use the entire signal with no reconstruction. However, I recommend using either this value or using 9 IMFs, which is what usually generates the more standard results, the more general results. Here we have an option to load the trained network. We have a trained network already available. Now, why is this option there? The main concept is that you may use this model and this application, but you may want to train the model with your own signals, with a different database from the one we used, and then try to use this application. This is the reason why this button is here, so you have that flexibility. And finally, we can classify the model. Now, in this particular case, the signal is abnormal with 97.9397%. Now, if we are going to use this for a simple study, this should be enough. However, if we are going to study a patient and we are going to be constantly working on the same patient, and we want to have a history of what's been going on with that patient, we can save the patient information here and add this result to this table. If we have done that previously, this is what it would look like. We will have a name with an age, the sex of the person, a phone number, and some previous results. And now we can add this one to the table. Now, let's say that we have a new signal from the same patient. We load the other signal. We classify the signal, and we see that the signal is normal with 66.96%. Now we can add this new result, and we would have all this table with all the results that we have been using so far. So we can have some reference of this patient. We can study this patient with the history of the results we have obtained from him. And we can finally save the results. We could use it in this same file. I'm just choosing not to overwrite it, but we could if we wanted to. And in the future, we could just load the file that we just created. And that's pretty much for the application. Thank you very much.